So now let's think about the pharmacokinetics, which how does the body do to this drug or molecules when we measure the amount of molecule in our body over time. Then we can see how these drugs kinetics in the body. So in terms of elimination, here I brought like some typical molecules in our body as a parent compound called nicotine, caffeine, and ethanol for drinking. So this graph is a very important experimental graph. So you see relative concentration at 100% to it start to drops down over time. So here you can see caffeine, which is main active ingredient in coffee, and that decreases, like you see these curves, and more prominently nicotine here, which is also an active ingredient in smoking. So you see this blue line, it drops faster initially, and it gets slower. The rate of decrease gets slower and slower. So how can we describe this behavior? So we can see the rate of decrease seems to be relevant to the amount of remaining elements. So if it's more amount is remaining relatively, the slope is faster, and the less amount is remaining, the slope is smaller. So we can kind of mathematically model how this behavior is happening. On the other hand, there's an interesting behavior by ethanol, which is also the alcoholic drink. When we drink, this is what ethanol is, what matters. And you see very interestingly, ethanol decrease seems to be linear. So the rate of change the rate of decrease doesn't change over time. Okay, so let's just think about that. Other molecules are converted to other, some molecules are converted into another molecule by chemical reactions in especially liver, a process we call biotransformation. An example here is elimination of alcohol because it's potentially toxic molecules. And now let's talk about kidney. The most important organ for maintaining our internal environment is by far the most important is the kidney, which keeps our balances of homeostasis. What does the kidney do? First, it has a sieve by itself, so that directly filters, especially small molecules, not like protein, because we don't want protein out of our body. So filtering blood, and the second is removing small molecular waste products. So removing from our body these small molecular weight products, and most importantly, it regulates the concentration of ions for maintaining our normal function of our heart, brain, and muscles, especially, for example, sodium. Sodium concentration is high outside of the cell. For example, in the brain, the neurons and the cells, sodium concentrations are about 10 times high outside. And kidney's function is to make these concentrations of very important ions to keep in our body. So let's get to the nicotine. So this is a chemical, this shows the chemical of nicotine. So nicotine for smoking, not sure whether you have a smoking friends or yourself or your parents. My daddy once smoked, so I know about this. And also this nicotine is readily absorbed through the, you inhale, so through the lungs, and that gets directly into our bloodstream because of the circulation exchange in the lung to the capillary. So once inside the blood, it stays in the body until it's eliminated, or primarily by biotransformation, of course, in the liver, to compounds such as nicotine, which are rapidly eliminated by the kidney. So the duration of this action of nicotine in the body should be determined by the rate of conversion of nicotine into other compounds, the metabolites of nicotine. So you see, I have friends and I've seen my colleagues who smoke. They usually come outside maybe every hour or every other hours. So you can see, yeah. So the nicotine pharmacokinetics in the body. So half-life of nicotine is about 2 hours, and thus the physiological effect of smoking a cigarette. So once my teacher told us that, wow, when you're walking, let's say in a seashore, having a cigarette versus no cigarette makes a huge difference, he said. With a cigarette, there's a lot of things you kind of coming into your brain. You can start to think something, and you remember many creative writers, and many of them like enjoys smoking. So the smoking cigarette, of course, that nicotine's effect is increasing blood pressure, so that it actually gives more blood and stimulates the brain. So that may be why people love smoking, and it also does have a addictive element too for several hours. Oh, let me go back a slide more to see about the duration of the action. So look at here, nicotine. So in this kind of graph, an easy way to define how quickly it decreases from 100% is a simple way. Just take a 50% and measure the time to reach by half. So we call it half-life. So in nicotine case, let's see 0.5. So it's about, you see about 120 minutes or 2 hours. So that's what we saw it here as a half-life of nicotine, about 2 hours. What about coffee or caffeine? So the half-life is longer. It's even 5 to 7 hours, and thus its biological effect for many people, it actually wakes up. So caffeine is also metabolized by biotransformation into other compounds in the liver. And the rate, so interestingly, so because of that, so I sometimes enjoy drinking coffee, but I tend not to drink coffee late afternoon because it may interfere with my sleeping. But in the morning, probably okay, because this half-life is about quite long, let's say about 6 hours. So I wouldn't drink coffee after 6 p.m. But I have a friend who say, hey, I have no problem sleeping by coffee. It happens that he's a smoker. So I was curious, so what happens to him? Why he has no issue, even he drinks coffee, which is of course including caffeine. And actually I found this, the rate of elimination can change, especially the half-life can decrease to 3 hours in smoker, which is interesting. And I realized why. My friend who is a smoker, he said it doesn't really matter whether it interferes with his sleeping or not. Now let's talk about alcohol. Alcohol is converted to a toxic compound called acetaldehyde. And by the action of enzymes such as alcohol dehydrogenase within cells in the liver. Yeah, this is using to to biotransform alcohol, you need water. So it's a good idea to drink enough water when you are drinking. So here, the rate of alcohol oxidation is relatively constant, as I said. So unlike the other caffeine or nicotine's curve in the body, alcohol is kind of constant. What does that mean? It somehow means that there are enzymes which convert this alcohol to metabolize this, but it's constant irrespective of the amount of alcohol. That means the amount of the enzyme might be not that much that it's always saturated. It's just working at its high speed, but because of that, the rate of decrease of this ethanol is constant. So we call that as a not first order kinetics, but zeroth order reactions. On the other hand, the caffeine and nicotine, which I showed you, that it seems like the rate of conversion seems to be relevant to its relative amount. So that's more easily to describe as a first order kinetics, which means the rate of change is proportional to the amount, which happen to be usually exponential decay function. So what does this zero order reaction means? Meaning that the enzyme is almost saturated. So enzymes keep working while the amount of alcohol is still abundant. So you can't convert more. So the byproduct acetaldehyde is toxic and it's further converted into acetic acid by another enzyme. So you can see it's not very good idea to have a heavy drinking because you can accumulate this toxic product. So that leads a long-term alcohol abuse can lead to liver failure, okay? Because acetaldehyde's direct effect on your cell. So this is a little bit of a biotransformation from a chemical compound, which is could be maybe not good for your body. So I brought another example of the another way, so called the prodrug. So let's say in cancer therapy, there is a famous chemotherapy drug, which is involved in preventing a cell proliferation. So those proliferating cells, it affects as a toxic so that the cells can die. But then when you ingest or administer the drug, you don't want this drug to be already toxic to your, let's say, gut. So now there's an interesting concept of prodrug, which means we give inactive molecules that will be metabolized into an active drug after when it passed through the liver after biotransformation by the liver enzyme. So a famous chemotherapy drug called cyclophosphamide, or it's known as a 5-FU. So this drug is, let's say, administered. It's not toxic by itself because it's prodrug and it doesn't do its effect until it gets metabolized inside the liver, and it becomes a potent and active drug, which will try to interfere with rapidly proliferating cells in our body, including cancer cells. So, okay, now the next time we will discuss about more detail in the Q&A. Thank you for your attention.